All right, because we know that f of A is negative 2 and f of B is positive 2, would we have a solution that is a root or a 0? Would we have to have a 0? So would 0 ever be between negative 2 and positive 2? Yeah. Okay, so the intermediate value theorem tells us that because one of these values is negative 2 and the other one is positive 2 and the function's continuous, that you're going to have a 0 in between them. That's all the theorem states. So, when you have problems with the intermediate value theorem, all you have to do, all right, is think about it. Think about my graph. Okay? And here's negative 1. Here's 4. We need to know if there's something at f of negative 1. All right, and something at f of 4. So we need to plug in those values on the interval in order to see where these things are going to fall, whether they're on the positive side or the negative side. Okay, if one's negative and one's positive, doesn't that mean that 0 has to be in between them? It does. So that'll kind of help us out. Okay, so we are showing that the equation has a root, which also means a 0 on the given interval. Okay, this is y'all's example 1, I believe. All right. So if I plug negative 1 into this, so what is that? 2 times negative 1 to the third minus 8, negative 1 squared. Okay, if I plug all that crap in, what is that? Negative 2 plus 8 minus 5 minus 2.
Wouldn't it be minus? Why is that minus 8? Because the negative.
Oh, you're right.
Wait, it's where you did. Oh, okay.
Y'all good? So negative, what, 17? Don't you got?
Yeah.
Okay, so at f of negative 1, you have negative 17. So it's way down here. Okay. And we know that polynomials are continuous functions from the other day. Polynomials are continuous everywhere. There's never a hole in those. All right. So now you got to plug in 4. Okay, some big numbers. F of 4. Well, you got 2. I'm gonna write this weird just to kind of help you all out. Times 4 times 4 times 4. Well, watch what I do. I'm going to show y'all a trick. Plus 20 minus 2. Y'all good with that? Yeah. All right. What do you notice about this? What's 2 times 4?
8.
So this is 8 times 4 times 4. 8 times 4 times 4 minus 8 times 4 times 4. It's the same thing. Yeah, they cancel. So that's why I wrote it like that, just to show you. All right, they cancel each other out. This is going to go to 0. So this is what? 18?
Yeah, first of all.
Okay.
So you saying 2 times 4.
So here at 4, we have a value up here at 18. So if my function's continuous, no matter what it does, right there, oop, that was a crappy curve. All right, does that guarantee that I have a root? Does it hit the x-axis?
Yeah.
Yeah, here's my root. So we have shown, all right, by IVT, that this does have a root. That's all I was asking you to do. Okay, there's a 0 right there.
I'm good till you start adding all this cosine and sin.
I know, the trick stuff is kind of where it gets a little weird. But we can do this together. All right. So look at your example 2. Okay, does the intermediate value theorem guarantee roots for that on the interval from 0 to pi? Okay, so we've got to know some of our unit circle. First step for doing these is plug the things in on the interval. So the first step, I'm going to try f at 0, which is 5 cosine, all right, of 0 plus pi, which would just be pi, right, times the sine of 3 times 0. Can I just put 0 in there? Minus 0. Okay. So this is really 5. I'm just going to write everything out. I'm not going to skip steps here. The cosine at pi times the sine at 0. Can I leave off minus 0? Is that okay? All right. What's the cosine of pi? Cosine at pi is -1 times the sine at 0. What's the sine at 0? 0. So what's this whole thing got to go to?
0.
Oh, look at that. That's nice. So this whole thing's got to go to 0. Okay. Do I really need to do the other one?
No.
If this is a 0, does it have a solution? If it hits 0, it's got to have a solution. All right, that is the solution. Okay, 0, 0 is the solution. But if you wanted to verify, since we need practice with our trig, okay, if you were taking the AP test, they'd probably want you to do this too. All right, f at pi. So now we're going to plug pi in for all those x's that we have. So 5 cosine of pi plus pi times the sine at pi minus pi. Okay, so this is the cosine. Can I just put 2 pi here? Times the sine of pi minus pi. All right. Well, just like the last example, what's the sine of pi? Huh? Oh, yeah. 3 pi, sorry. 3 pi. I forgot my 3 in front. There's a 3 right there. Thank you for keeping me on track. But, just like that, pi is the same as 3 pi, though, right? Because this is 2 pi. One more time gives me 3. So what's the sine at 3 pi? So this whole thing's multiplied by 0, so that basically cancels that part. So you got 0 minus pi, so this is negative pi, right? Ever hear with that? Okay. So is there a solution on the interval? So you have, there's 0, 0, 0, and then at pi, your value is negative pi. So it's continuous. Is there a root in there? Does it hit the x-axis? Yeah, where does it hit the x-axis? 0, 0. So 0, 0 is the solution. Okay, because that one was in between. Okay? Does that make sense?
Yeah.
All right, let's get it. So, if I'm finding limits from a table, okay, it's the same as finding limits from a graph. It just looks a little different. So, on number 1, notice we're looking for the limit as x approaches 3 of f of x. Okay, so for the limit to exist, the limit from the right-hand side... Oh, y'all can't see this? Okay, the limit from the right-hand side, so 3 from the right, has to equal the limit as x approaches 3 from the left. So, that doesn't necessarily mean that f of 3 exists, correct? Because it could be going to infinity at 3 and then have a dot at 3. Okay? So, look at our function here. So, as x gets really, really close to 3, so look at 2.999. What does my y value go to? All right, 100,000. Okay? Right before that was 1,000. So are my y values increasing really, really quickly? All right, so what would y'all say for a really, really big number increasing really, really quick? What is that limit approaching? Infinity. So from the left-hand side, as we approach this from the left, it goes to positive infinity. So this is positive infinity from the left. How about from the right-hand side? All right, so this goes to negative infinity. I would agree with that. So does the limit from the right-hand side match the limit from the left-hand side? No. So no matter what this is in here, okay, at 3.001, what would we say since these don't match? This is D and E. Not too bad. Can I go to the next slide? Okay with that? All right, we're going to do number 3. Okay, so 2.99. Again, this is as x approaches 3. Okay. So, always ask the question, does the limit from the right-hand side match the limit from the left-hand side? So the limit from, as we approach from the left, what does it equal?
Negative. Oh, negative. 7.2.
Yeah, 7.215. What's the limit as we approach 3 from the right? Okay. Do these limits match? Yes, so the limit as x approaches 3 is actually equal to negative 7.215. Okay, even though f of 3 is equal to 4. Okay, so this is one of those cases where you have a hole there, right? There's still a limit, but it's not continuous. It's not differentiable there, so I can't tell what it is. So number 6. Okay, what do y'all notice happening here? All right, what do they only give us? So they only give us the left-hand side. So all this stuff is leading up from the left, 2.999. Okay, 7.999. 3 is 4, though. It jumps back down to 4. Golly. All right, so what is this limit? How would I finish writing this? X approaches what value? 3 from which side? The left. How would I write that? Yeah, with a little negative sign up top. Okay, so this table is telling me 3 from the left is equal to 7.999. That's it. I'm just reading the table. There's not really work to do on this besides reading the table. So that's it. That's your answer. So all I'm doing is I'm reading that I'm coming in from the left toward 3, and my limit is approaching that value because it started at 7.9. Okay? Excuse me. What's it getting really, really close to? 8. All right. So you could put that, or you could put 8. Okay, either one would be acceptable there. It's kind of up to interpretation in a lot of cases. Does that make sense?